Hello, so we need to jump into exception handling, and this is chapter 14 in our textbook. Because of that, I'm going to go ahead and create a program that's called chapter 14.cpp, and I'm just going to discuss a little bit about exception handling here. Okay, so exception handling is basically a way to manage runtime errors in the program. Instead of letting a crash occur, we let exception handling to detect the problem and direct the program to a different flow of execution. This means our program stays running when we handle some kind of a problem. In fact, when the problem occurs, we throw an exception and we catch that exception somewhere else in the code. It's going to look kind of like an if-else loop or an if-else structure, but it allows us to take appropriate action like notifying the user or clearing up memory. And just to kind of show you what that looks like, I'm going to go ahead and save this. And I am going to I don't know why I put a dot in there. Oh, okay, cool. All right, let's save this. And okay, so what a try catch statement, what the try catch block looks like is we're going to have try, and inside this try, we're going to have code that may cause, or I'll just say throw an exception. And then in our catch side, this is our catch block here. The catch is going to be the code that handles the exception. So if an exception happens, then then we jump to this part of the code. So you have the code that handles the exception, code that may throw the exception, and the code that handles an exception. I should write that correctly. Okay, so let's look at each keyword in detail. This try block wraps code in a way that might cause error. A throw statement, so it'll be inside. A throw statement is a signal that something went wrong. So I'll go ahead and say this here. And the catch block receives and handles the error. So let me put a main method here, and we'll talk about what this main method does. Okay, so this main method, it assigns 10 and 0. So it assigns number 1 is 10 and number 2 is 0. And then it's going to tell us if number 2 equals 0, then throw the division by 0. And otherwise, it's going to output num1 is num1 divided by num2. And we're sending in an error, and it's going to output that error. So let's go ahead and run this code. All right. And there it is, error division by 0. And the error is called because number 2 equals 0, and so we're throwing that as an error. This particular string literal gets passed in to this catch, and that is what's output there. So we are actually creating an error message for the user. So the catch block intercepts that error and prints the helpful message. Okay, what if there's multiple exceptions? Well, you can have multiple different catches. So let me show that. Let me jump in and create a new method. I'll put up here or new, I should say new function. And we will put this in here. So we are going this particular code C++ matches the thrown value to the first compare incompatible catch block, so order matters, because it is an overloaded method. It said because I threw a 5, it's going to come here to this first catch because that's the integer call. If it's a string, it's going to send it to this character array, right? And so, yeah, so you're basically overloading the methods based on catch type. All right, so if you don't know the exact type, you can create like a catch-all function or a general fallback, and it's going to look like this. We'll kind of change this real quick, and let's put it here. Let's just say this. These ellipses basically tell the system that we don't quite know what error this might be, and so it's just gonna catch it anyway. If it's not an integer and it's not a string, it's gonna go to this next catch. Let's put this in the same format. All right. What's wigging me out is that my colors are not. It's not showing the code correctly. So I'm gonna go ahead and close that out and reopen it. It's still doing that same thing. Anyway, I'm not stressing over it. We're gonna keep moving. All right. So C++ creates a standard library of exceptions, all derived from the base class exception. And there are some common classes, and that's runtime error, logic error, out of range, and invalid argument. So I'm going to go ahead and come to the top of this and say common exceptions. And then it looks like that. We have from that exception, we have logic error, out of range, and invalid argument, and runtime error. All right, so you can catch using the standard exception library. So we will use that here. And I will show you what that looks like. Go ahead and put that in here as well. So we want to, I don't need that std because we're using the namespace std. And it's telling me that the default handler is airing that out. So let's put this here to put the default handler at the very end, which is where it should be. That's another thing. You want to make sure that you put your default handler at the end. I got a double block here. Need to fix that. Okay, that means that now but what happens is this: if I put the default handler above the standard exception, it's never going to get to the standard exception. So in this case, it's going to check for integer, it's going to check for the string, it's going to check for the standard exception, and then if it doesn't find anything, it's going to just say an unexpected error has occurred. All right. Now you can also create custom exceptions. All right, and that means you can use standard exception and you can override what the standard exception does. And let's just build our own exception real quick. I will do that by overriding this, and it'll look like this. So class my exception from the public class. And this is going to be something similar to an object, but we're just making an exception. So and we're overriding what happens in the standard exception. And we are just going to return custom exception occurred. All right. And because we're defining that class, I need a semicolon because that is its own statement. Okay. Now in this case, now we have this myException class. So if we're going to catch that, we need to catch myException. So it will look similar to exception, but it will be myException instead. So we'll go ahead and kind of paste that in. All right, so we'll say my exception. And we will just, instead of having this statement in there, we will take this out. All right. This lets us create domain-specific errors in the program. This is a great practice in large program builds. Older versions of C++ allowed functions to declare what exceptions they might throw. But now we use noExcept to mark functions that never throw. And the way that would look is if we were to make I'll just create a shadow function here. We would write something like this. It would say void, this is this function. So basically when you're using exceptions, use exceptions only for exceptional conditions, not normal flow. Do not catch what you cannot handle. Prefer standard exception types over well-defined custom ones. Always clean up resources before throwing or use the resource acquisition is initialization. And let's show a simple program that catches some of the exceptions. And actually, I'm gonna build a program now I'm gonna show you a program now based on this new function that shows each one of these exceptions being caught. And the way we're gonna do that is we're gonna go ahead and make a switch case here. So I'm just gonna say we're gonna make the new function a void function, and we're gonna pass in a choice. And we are going to use a switch inside of choice to show this working. Okay, so now we have the choice happening, and we'll throw each one of these errors. And then in our main method, which is here, we are going to just call new function and see what happens. Okay, so let's go ahead and Void new function. Oh, I see what it's saying. Because we've overridden that, so. See if this fixes that problem. So the problem in that time is we overrode my exception from exception, so I need to catch my exception first before we go to exception. All right, so let's go ahead and run this, and you can see now that we called my function 1 and it caught an integer, caught a string, caught an exception, custom exception, and an unexpected error occurred. Okay, so what happened is this. I called from main, I called new function 1. And when it called 1, I had it throw an exception of 5. Because it was 5, it came down to the catches and it says, okay, this is an integer, so it caught an integer. And it did the same thing each time. When we caught a string, it passed it here, etc. All right. So what we covered today is how to handle exceptions, how to create those exception problems, and how to handle it. This allows us to try, throw, and catch different exceptions we want to generate. And you can do this before you have, these are like pre-catch things. So you can say, look, I want the user to input an integer. If they don't input an integer, let's catch that and resend the user back to this. So we're not going to have so our code's not going to break. So if you're building code, for example, that expects an integer, or you're building code that divides something, you want to make sure you don't have division by 0. You want to make sure that integers are presented. You want to catch these things as your program executes so that your program doesn't die in the middle of the road, because users will do anything possible. Users will do the thing you don't expect them to do when it comes to your code. And so that kind of wraps up chapter 14. Just go play with exception handling. The more you play with it, the more it'll make sense. And we'll see you in the next video.